Well, here we have chassis number 3 for the same person. The previous 2 chassis were both the 25-inch 2501, which is the medium res version, and this is the standard res version. This is the 2515C. Well, actually, technically the standard res version of those would be the 2500, but this is the 2500 series, if you will. So 2515C is what this one is. And this one also is in not working condition. I don't know anything other than that. It looks like somebody has changed a couple of caps, but for the most part they're all original. Just from looking at the neck board, someone's changed this cap at least, or added it, I can't say. But if we give it a good look over, I don't know what's wrong with it. Like I say, they just sent it to me as not working, and it was missing the neck board. So if you're familiar with the problem 2501 from a couple of videos back, this is the neck board from that one, because this one was missing the neck board completely. Oh, I'm sorry. Remote board. The remote board was missing completely from this chassis, so I had to pull the remote board off of the first 2501 that we did that came with that one and use it for this one. It's the same remote board, so we should be able to use this one fine. But this one does not have a remote board with it, and the owner of this doesn't have one. He is asking where he could get one, and the only place I know of is just from a parts board or parts chassis. So we'll get this up and running and working, and then at some point he'll have to find a remote board, and then once he does, he can plug it in, and this should be good to go. So again, this is not working condition. I don't know what's wrong with it, so we'll start with a good cursory look over. And one of the first things I noticed was that the corner of the neck board is broken off. We can see here the corner is completely missing, but it's not a big deal because it's just part of the ground plane. As you can see, the ground plane is still connected right there all around here, so that's not going to be an issue at all. But the actual neck board itself really is in pretty decent shape. There's nothing really wrong with it that I see. We don't have any over-exerted control resistors for the colors, and everything appears to be intact. We're not missing anything, so the neck board appears to be in good shape other than the missing corner. I did notice almost immediately that the degauss pins, one of the pins is missing. It's just completely gone. I think it got broken off, quite honestly. But I have a couple of donor chassis here that we can use to pilfer. Oh, gotta turn it around. We can pilfer one of the pins off of it and put it on here, and should get that good, or get it back to where we can actually use the degauss coil, or degauss coil, however you want to say it. I say Gauss, but I've heard people say Gauss, so really however you want to refer to it as. But and let's take another look around here. It appears to be relatively good shape. Don't see any missing components. B plus pot is dead center, right about where it should be for 125 B plus. I don't see any bulging caps or any signs of leakage. Yeah, somebody has done some caps on this. I wonder if it's a whole cap kit or not. Nope, because that one still has the glue on it. And this one has the glue on it. But these don't, and these don't. And this one doesn't. There's no glue on the caps, or this one. So somebody, but all these green ones are original, I think. But anyway, so someone has done a partial cap kit, probably trying to get this fixed. So it doesn't bode well for us, but I don't see any real issues. So let's look at the backside. Except for this, I think that's about the only thing I've noticed so far. Let's look at the opposite side here. Yeah, there's flux signs around the cap, so someone's done a partial cap kit at least, and it looks like someone's got a jumper here for some reason. Not sure what this jumper is for. It shouldn't connect to, this should not connect to, maybe it's a ground jumper? I don't know why someone would do that. It doesn't appear to go to anything. They're not connected to each other in the circuit. So why would that be there? Well, somebody put it there on purpose, so I'm not going to mess with it just yet. Let's try and get it, let's try and get it operational first and then try and figure that out. Well, okay, let's do our usual testing here. Since everything passes visual, let's remove the leg here from R117 and see if we got any power supply problems. Okay, that's out. And that is successfully extracted. So let's grab, that likes to get, I need to flatten that. Someone's removed that. See this? Someone has removed this resistor. When they put it back in, they didn't flatten it back down because you can see the glue there. It used to sit flat. And it's obvious it's got signs of rework here. I wonder if I can flatten that back out here. Yep, there we go. All right. Okay, I think that'll do. That is much better. All right, so get this cluster out of the way here. Figure it out. Okay, so let's get our meter. Not that we really need it, but I'm just going to make sure that we're getting voltage. How far do we get? There we go. And again, like I mentioned in the last video, we can the heatsink here has a very convenient hole that we can just boop, put our negative lead right in there. Let's grab a couple of alligator clips. And we'll clip onto our positive, and we'll clip this on here. And we don't need one for negative, so let's, all right, I don't know why I always grab two, out of habit, I guess. Let's plug in our voltage power. Okay, we got 117 out. We're hooked up to read our B+ DC voltage. We're plugged in. We got a ground connected. Let's grab our light bulb. And we'll hook up another lead here. Okay, let's turn it on. We're hoping to hear a click and hear the noise of the transformer winding up, and then we'll test our power supply section here. So 1, 2, 3. Our power supply section is dead. D-E-D, dead. Off. We got nothing. On. We have absolutely nothing. Is our fuse good? I guess I didn't check that. Let's go to continuity, and fuse is good. Okay, but if we go back to volts DC, we are hooked up to 117. We are hooked up on our meter. We got ground. Turn it on, and we get nothing. No sounds, no clicks, no energization, no nothing. Well, that would definitely account for a not working chassis. We'll leave 117 out, and I mean, it's totally dead. Do we have the same exact problem as the first 2501? I think R106 was open. This resistor right here, R106, was this guy right here. This guy was open on the first 2501 we had that had a fully dead power supply. So let's go and see if that... It's supposed to be 800K. It's 800,000 ohms out of circuit. And in circuit on the good chassis, after we fixed it, was probably around 1.2 meg or so. But let's just see what this reads in circuit here. Look at that. Negative open? Negative open? That's an odd reading. And we are dead open. R106 is open. Well, we're not getting a reading on it in circuit anyway. So let's remove it. And I don't have my desoldering station operational, so we're going to caveman this out of here. We're going to heat up the pad and lift it out of here. R106 is right here. And it has been extracted. And if we lift it up, we can see that it is now out. Right here, it is out of circuit. So let's measure it again here, out of circuit. And what do we get? Leads are good, 0.1, and out of circuit we get, oh, it's good, 800K. So R106 is not the problem. 800K, you see there 0.8 mega ohm, which is 800K. So R106 is not our problem. That's why it's important to check things both in and out of circuit. So let's get this guy back in here. If we're going to be able to. I'm going to say probably not. You think you could just put it back in and not have it give you problems, but that's in a perfect world. There we go. All right. I don't have my fan going or my extractor. I should have my extractor on. All right. Well, that is not the problem. So in that case, it's most likely our switch mode power supply chip. This guy right here, like I thought it was the first time on the first 2501 we worked on, because that one was dead as well, dead as a doornail. So let's check and just see if we have any odd readings. I think we should have a diode here, and nope, that's open. Diode here, nope, that's open. Our chip is dead, guys. Our switch mode power supply chip is absolutely bad. Well, let's just look at readings here previously before we change it out. Let me turn the desoldering station on. So if we read it, it's going to make a noise here. Hang on. The fan likes to, the bearings are going out in it. And I have to wait for it to get to what looks like 100 degrees Fahrenheit, then I can bang on it and that noise will go away. Okay, you can hear it. Now listen. Now it's gone. So I need to get a new one. But anyway, so let's go negative here, positive here, and we get nothing. And if we go negative here, positive here, we get 1.3, but that's not right. So that's not right. We get nothing there, nothing there. If we switch our leads, okay, 1.9, nothing. We get a 0.7 voltage drop there, but I think that's wrong. If we flip the leads around, we get 1.8. But on these two pins here cross each other no matter which way I go. Well, now wait a minute. Don't do this shit to me. What are you doing here? 0.6. I don't think that's right. Well, we're going to change it anyway because I think that's the problem. I don't know why it wasn't giving me a reading before, now it does. It's not a, solder joints are fine, leads are fine. Who knows? That's just the way these things go. All right, well, let me grab, I've got a bunch. Let me see here. I've got them in here. It should be close to the top from the last time. Of course they're not. Well, time to dump the purse out here and find them. Vertical ICs, pots. There they are. Nope. No, wait a minute. Yeah, I put them in here, didn't I? I thought I did. I thought I had them in here with the 74, 7500 stuff. I guess not. My mind is going, Dave. my mind is going. Do I just... There they are. I didn't put them back in the bag. There they are there. All right. So, I am fairly confident that we have an issue with the switch mode power supply chip, and I got 4 of them right here specifically for the Neotec, and they are different. These are different from the 74, 75, 2000, 5000. They both use a switch mode power supply chip just like this, but the Neotecs are different, so you have to order the specific one. And it's part number TDA 4605. I can't see through the viewfinder. 4605. TDA 4605. So, yep. Let's throw one of these in there and see what we get. Let's do one of these. All right. So put these back in here. Set those aside, set this aside. And let's get this out of here. And I was gonna say it should have fallen out, but if we give it a little help, there you go. So we'll set that aside as well. Now let's grab our replacement and put our replacement in here. And it goes like, you're gonna make sure you line up the notch so it goes like this, right in there. And there you go. So we'll hold it in place while we dab a little bit of solder on a leg to keep it from falling out. Like so. And then we can go hit the rest of them here. Okay, now, just out of curiosity's sake, let's take some readings again. And I think these two didn't give us anything. Yeah, see, now we got a diode there. Boom, 0.5 voltage drop. 0.693, I think that was 0.7, so that's the same. And then we had voltage drop here, yep, okay. And, alright, well, I am confident now that we have voltage drop across these two pins that it's probably going to work now. So let's flip this back around. And go back to volts DC, put our ground in here. Hook up our power for B+, put that in there. Hook up our connector for our light bulb, and you think it'll work now? Any guesses? Any takers? Let's find out. Okay, so I think we're ready to go. 1, 2, 3. There you go! And what do we have here? Light bulb lights up, imagine that. And we're at 118, that's too low. Let's turn this up a bit. You know what, let me turn this off. And let's wipe this back and forth. Like last time. Just to clean it up a bit. And we'll set it to roughly there. Now let's turn it back on. And we're at 116, so we got to go this way. Now we're at 124.3, which probably is going to be okay. Be closer to 125 once we get the full load on it. So, all right. So we had a confirmed bad switch mode power supply chip. There you go. So I'm gonna take that, throw it right in the garbage. Take my other ones here, then put them back in my parts bag or parts box, if you will. And now we're gonna have to discharge this. So if we take one of our leads here and just touch the frame, we want to discharge it, because right now it's still got. Oh no! Did it discharge itself? I think it discharged itself when I disconnected it from the meter. So if we touch this, yeah, it discharged itself. Normally you gotta zap and discharge the filter cap and stuff, but it automatically discharged itself. So. Okay, let's get 117 back in, and then let's test our HOT. And if the HOT tests good, then I say we give it a try just to see if it works on a tube, and if it does and doesn't have any major issues, we'll cap it, reflow it, fly back, test it again, and call this a quick and easy fix. Alright, HOT is again this guy right there, so we want to test on diode mode, and our negative lead on the collector, and we should have 0.5 or 0.45 voltage drop to the emitter and the base. So here's the emitter, 469, and base, 469. HOT is good. I'll bet you it'll fire right up. I am curious about what this does though, this jumper, because that's not supposed to be there. Well, at least, let me look at the two 2515Cs I have over here. This one here is a parts chassis, and yep, no jumper. And I've got another one here, and yep, no jumper. So I don't know what that jumper is supposed to be doing. But if it works and operates, I'm going to leave it there, because obviously somebody put it there for a reason. So let's get a tube over here and hook this up and see what happens. Alright, so we're actually using a K7000 tube and yoke, because I don't have a dedicated Neotec 2515C tube and yoke. However, the 2515C and the standard res series of Neotecs are completely compatible with all of the standard res K7000 line. I'm sorry, the standard res Wells Gardner line. So for instance, the K7000, the 7400, the U2000, even the U5000, that's a special breed of yoke. Even the Henrex Polo, things like that. So all the standard res line of chassis should be, tubes and yokes I should say. Most of the standard res line of tubes and yokes are compatible with the Neotec standard res series as well. So we're using a K7000 series tube and yoke here for this testing. We're all hooked up, anode, neck, yoke, ground, power, video, remote, and we're going to be using, just for quick testing to make sure it operates and see how it looks, the test pattern generator. And we're set to standard, so let's turn this on. And I don't have a plastic protector here, so I have to just use a towel there so it doesn't short out on the test bench. All right, let's turn it on, see what happens. 1, 2, 3. Well, oh, look at that. Crapola. Complete collapse. Wow, okay. Can't say I've ever seen a Neotec in vertical collapse. I mean, that was, not only was it collapsed, but it was only, this much of the screen. That, it didn't sound correct either when I turned it on. That sounded odd. Now I understand why someone's done a cap kit, because they think they tried to fix the collapse with a cap kit. Well, let me try it again here, just out of curiosity. It does turn on and operate now, so at least we got that fixed. But it is collapsed. Okay, well, let's turn this back off. Well, we're stepping in the right direction here. Let me do a little bit more investigating, make sure I don't have any bad solder joints or anything that's visually wrong. If not, what I'm going to do is I'll just redo the cap kit, do the reflow, replace the flyback, and then we'll test it and try it again. And if it's still collapsed, then we'll go through. I'll probably test the vertical IC and verify that there's no shorted pins to ground that shouldn't be. Like for instance, the vertical IC is this guy right in there. I'll check that. If I find any anomalies, if I find anything worth reporting at all, or showing or anything, I will show it or report it. If I don't, when I come back, I'll have all the rework done, then we'll test it again. So let's see if I can find anything and where we're going to be at that point. Okay, so looking this over, I have found something that I haven't gone through and looked at the schematics for it yet, but R120 right here is supposed to be a 4.7 ohm resistor. And I was just sitting here looking over things and just doing another visual inspection, and it looked like R120 was a bit discolored. It's awful white, like it got very hot. So I looked at the bottom and the solder pads were all burned up. So the solder pads were all burned and blackened. So you can see how much heat has been, gone on. This resistor here, R119, has a lot of heat and discoloration on the pads and the traces, I should say, and also along here. So this area here and this whole trace here and along right here all got very hot for an extended period of time. So I reflowed R120. I don't know why I did that, because I reflowed it, then I checked it afterward. And if we check it on the bottom side here, it's supposed to be 4.7 ohms. And if we check it in circuit here, an ohms meter is good. In circuit, it is 5K, 6K. Oh, I slipped off, sorry. Now it's in the mega ohm, now it's 700K, 600K. Yeah, it's not 4.7 ohms. R119, I didn't check that. Let's just check it now. That's supposed to be 200 ohms, and that's correct. So we're at 200. So I think R120, I need to look in the schematics and see what R120 goes to. That's a resistor. It's not R120. It comes down here, goes across the diode, and it goes right to our vertical IC. So I'll bet you that's our problem. If we look here, this leg of R120 that isn't bad, if you follow it this way, it runs down here across this diode here. What is that? D501. It goes right across this D501 and straight to our vertical IC. Let's try to do this again here. Comes off of R118. It goes across here, down this way. It goes through this transistor here, but I think that's probably okay. Comes down here right to the anode of D501. Across D501 and straight to our vertical IC right here. So that very well could be our problem. So let's replace that with a donor, and then we'll try it again, just the way that it is. Out of circuit. What does this puppy read here? Should be 4.7 ohms. And it is completely open. How about that? Absolutely nothing. Leads are good. Resistor is completely open. Well, there you go. If that's not our problem, it is definitely part of the problem, so we'll set that aside. And I'll grab a donor here, and we will rob this resistor out of here. Okay, and if we test this one out of circuit, it's a bit warm. I just put a soldering iron on it, but it should be 4.7 ohms, and we get 4.9. Well, that's more like it. So let's get this guy in here and we'll test it again. I gotta clean this leg off here. One of these days I'm gonna learn not to even bother to try to put components back in until I clean the legs off, but that's all right. Now, I'm not sure if this got hot because of the power supply section going out and someone leaving this on for an extended period of time could have taken that resistor out. Most likely is what occurred, but oh, there we go. Okay, yeah, that pad is a bit damaged from being so hot, but let's solder this back in here. Okay. And there we go. Now, any bets on whether or not it will work after changing that out? I think we're going to have, I can't say with 100% certainty that it is repaired, but it should be at least better. So now, let's test it with the replacement in there. And what do we get? 4.9. 4.8 as it cools down, yep. So, okay, let's test it now and see what happens after replacing this open resistor. Alright, so we're all hooked back up. We got anode, neck, yoke, ground, power, video, remote, and we're using the test pattern generator again, so let's turn this on, and I am confident that this will work now, or at least be better. So I have the meter set up to read B+, and we can adjust as necessary if we need to. Yeah, so I can't say it's fixed, but I'm sure it'll be a lot better now that that resistor is not open. So let's see what happens here. 1, 2, 3. Something's clicking. And what do you know? Looks like we're missing blue though. Wow, 2 in a row missing blue? Crazy. We're upside down. We're upside down. We can flip the vertical, that's no problem, but it is working. We need to adjust our B+. That clicking that you heard is almost surely the flyback. But let's get in here and tweak our B+ to get to 125 here. Can't get better than that. Oh, I lost my ground here. Hang on. Hook the ground back up. 124.9. Perfect. All right. Well, we're missing blue and we're upside down. So let's turn it off and let's flip our vertical around. Take the vertical off and flip it around so yellow's now inboard. And we'll try this again. So yeah, open resistor caused complete total collapse. Imagine that. Alright, so let's try again here. No clicking that time. But are we up right side up? Yes, we are. Okay, so we need to figure out now why we have no blue. But our collapse is now repaired, and I'm not worried about this now because I'm gonna have to end up doing the full cap kit reflow and flyback and all the normal work. So I'm gonna do all that. Then we'll see if we can troubleshoot the no blue and kind of go from there. So let's see. Well, like last time, before I do the rebuild on the chassis, I want to see if I can figure out what exactly is going on with our no blue issue. And the last time we had a bad transistor. We knew that we were touching the control resistors here, and the one for the green was getting hot, the one for the red was getting hot, but the one for the blue was ice cold. So that's how we knew the transistor wasn't turning on. So we changed the transistor out and that fixed our no blue. But I don't think that's the problem this time. It could be, but we'll find out. Alright, so let's test the transistors first. Again, this one down here is green. This one is red, and this one is blue. So this resistor controls the red one, this resistor controls the blue one, and this resistor controls the green one. I say controls, but they're the ones that if you have this resistor out, it's going to be all blue, all red, or green, all green, that kind of thing. So yeah, the pots are in the center for the most part. That's green. So we got red, green, and blue are all center, red, green, blue are all center, and we had no blue. So first, let's test our transistors. Again, it's rather simple. We put our red lead on the base, and we should have 0.6 voltage drop to the collector and emitter. So if we go from base to collector, 0.6, emitter, 0.6, so that's the green one. Then we have our red one here, base to collector, 0.6, emitter, 0.6, and now our blue one, base to emitter, 0.6 and 0.6. So I don't think it's the transistor. Let's test our resistors, make sure they're 2.7K, give or take. Green, yep, 2.6. Red, 2.6. Blue, 2.6. Well, I've never seen the inductors be bad. We can test those with a quick continuity test. 904 is good. 903 is good. We know green's okay. 901, yeah. Solder on the next socket is okay, but could be touched up. It's not an issue of having bad solder on the transistor. And I'm wondering if it's the RGB encoder chip. I don't see bad solder on the pots. Well, we can swap the transistors, but I don't think it's the transistor because it checks good. And I should have tested for the resistors heating up, but I forgot to do that. But I don't think it's an issue with the transistor or the resistor or the inductor or a pot. Yeah, I have to suspect the encoder chip. Just for shits and grins, let's replace the encoder chip and see if that does anything. Because I've got some. Okay, so I should add that it's not as I'm sitting here doing this, I'm thinking about things, and I should add that it's not a bad solder joint on the video header pin on the main chassis. That's the first thing I looked at, and it's good. So it's not a bad solder joint on the main chassis, so it's definitely a neck board problem. But since our transistor checks good and our resistors are good, nothing else really has ever failed on one of these other than the resistor, the transistor, or the RGB encoder chip. So I'm going to slave a new chip in just to rule it out, and if it still has no blue, then we can kind of go from there. But with the transistor checking good, I suspect this encoder chip. must be ground. Yeah, we're gonna have to use the iron on that one. That one's ground. Yeah, I'm gonna need the iron for that one too. Okay, well, you wanna get nuts? Come on, let's get nuts. All right, let's clean this out again one last time. Set that aside, and this should come right out. Easy peasy, Japanesey. All right, so we'll set this aside along right next to our open resistor, and I've got some sockets here. I don't have the right size, so we're going to modify an existing one. And it needs to be roughly here. And here. There we go. Now we have a socket, and we can put that in here. And we're going to go this way with it. We got a bent pin, of course we do. We've got spirit. Yes, we do. We've got spirit. How about you? It's always fun trying to get this in here. All right, that is seated in there. And do we have all the pins through? Yes, we do. All right. Let's solder this puppy in. Oh, damn iron went to sleep. Ugh. 378, 379, 385. Okay, there we go. The iron, after a while, starts to go to sleep, and you have to hit one of the temperature buttons to wake it back up. But, you know, in case you walk away, as a safety precaution, that kind of stuff. But all right, back to 500. Sorry about that. 550. That should be enough to get us started here. Okay, did we miss any? Nope, it does not appear that we missed any. They all look fairly good. Okay. I think that should work. Yep. Now, let's grab a replacement. I've got a couple right there. All right. Set this aside for now. And let's make sure we get this in properly. The notch goes this way. These stupid film caps, get out of my damn way. Oh, and it's backwards. That's why you always double check. We certainly would not want to put this in backwards. Okay, there we go, and let's make sure that's lined up properly, and let's snap it in. Bada boom. Alrighty, well, there we go. So let's get it hooked back up, reconnect it to the main chassis, and we will try it again. So here we go. Okay, we got the replacement RGB encoder chip installed in the socket, and everything appears to be okay with that. So let's get this one more test here and see what we got. Oh, I forgot to hook up power. Of course, it's the other way. There we go. Alright, so now we have anode neck, yoke, ground, remote, power, video. Let's turn on test pattern generator. I have the vertical connector hooked up the proper way to have it up and down instead of backwards or upside down like last time. So let's see, do we have blue? 1, 2, 3. Now that ticking is a flyback, but do we have blue? Yes we do! Bad encoder chip as suspected. Bam, look at that. So we are back in business. I'm not going to bother trying to adjust anything at all. We appear to be working, and that snapping, yeah, that's definitely the flyback, so that's going out. So yeah, it is operational and working. So far we have a bad RGB encoder chip, and we have a bad, what was that? That was R120, I think that's what that was. So far 2 bad components, and the flyback is definitely faulty, so we'll have to consider that faulty. So we'll call that 3. But let's now let's do the teardown and the full rebuild, and we'll do final testing and adjustments after that. So here we go. Okay, all rebuilt, reinstalled, and ready for testing. I got the flyback replaced, full cap kit, full reflow, everything I normally do is all done. And I also installed a replacement pin for, oh, you can't see it. Let's move some of this out of the way there. Well, let's go over here. Okay, the degauss coil, that missing pin that was, well, missing, I got a replacement installed off a donor board, so we're good to go for that. And that should be it. So far we had a flyback that was chirping and making all kinds of ticking noises. We had a bad RGB encoder chip, and we had a bad R120 that was causing vertical collapse. So if this operates and works, that should be all of our problems. I have not turned it on yet. I want you to share the knowledge with me. We know it worked before, so if something happens now, we know it was induced by something that we did. And I've got the remote board here again on the towel, so we don't accidentally short out something on the metal workbench. So let's test it out. Here we go. 1, 2, 3. Okay, comes right on. And I'm using a Mortal Kombat PCB. so we can get the right screen size, position, colors, and everything ready to go. The screen pot is all the way down, now that I think about it, because these all ship from the factory with it all the way down. Let me get this, in anticipation of this actually working, I went ahead and got the tripod set up here, so if I can get this stupid thing in here, it's always a pain. There we go. And let's zoom in here a bit. Okay, let's turn the screen pot up till we get raster lines, which are right there. And let's zoom in a bit so we can see. All right. Now we turn it down till the raster lines just go away, which is roughly there. Oh, hang on. Right about there. And then we can supplement with brightness. And we turn brightness up until the background is not black, and then back down till it just goes black, which is roughly there. Then we supplement with contrast. Okay. Now we can adjust our focus, which is going to be here. Right there. Glorious. Look at that. Beautiful. All right, now let's zoom back out. Okay. Hot damn, look at that. Okay, let's do H position, which is here. Okay, that looks pretty good. Vertical position. That seems all right. Vertical size. Right about there. And now we got to do horizontal size. We'll grab the tool and adjust the coil. And go down. Yep, there we go. Let's wait for another screen here. And turn in the pot, turn in the pot, turn in the pot. Now we need to adjust our position slightly more. There we go. And let's turn it a bit more. There we go. We're a bit too green, but like I say, it's not a big deal because it's not staying on this tube. Well, if we turn the green down a bit and contrast up slightly, look at that. That is looking pretty good. Wow. Well, there you have it. Neotec 2515C, brought back from the dead. Oh, I forgot, because I already threw it away. But we had a bad switch mode power supply chip. I already threw that in the garbage, so I forgot to include that. So we had a bad switch mode power supply chip that was keeping it from turning on. We had an open R120 that was keeping it in collapse. We had a bad RGB encoder chip that was cause of no blue, and we had a faulty flyback that was causing ticking noises and chirping sounds and stuff when it was operating, so that was going to get changed anyway. But yeah, after a full reflow rebuild and replacing these parts, we are good to go. So I'm going to take these and throw them in the old garbage. There we go. And I'll let this run for a number of hours, make sure nothing's wrong, and we'll call it a success. So thanks for watching. Hopefully you learned something. Like, share, and subscribe, and we'll see you next time.